Today we are going to be starting our quadrant sampling. What do they call it? Population Field Studies Simulations Lab, quadrant and mark and recapture sampling. All right, so the first thing you need to do, sorry these shadows. The first thing you need to do is you need to watch that elephant, the Great Elephant Census video. And it talks about how they use quadrant sampling in order to estimate the population size of the elephants. So we're going to practice that in marine ecosystems, but before we do that, we're just going to do a little bit of a practice to make sure we know how to do density calculations and ratios. All right, so something you're a little more familiar with. We have 27 students and 9 teachers eating in a cafeteria that measures 9 meters by 9 meters. So that's not very big. Not okay for COVID. All right, so to calculate density, I'll pause for the bell. To calculate density, we need to find the total number of organisms. So we have 27 students and 9 teachers. So we have a total of 36 people. Okay. And you're going to divide that by the area. So it says that this cafeteria is 9 meters by 9 meters. So if we do that math, we're going to have what? 81 meters squared. So that means that there are 36 people in an area that is 81 meters squared size. Okay? So to calculate that density, we just simplify that to there are 4 people per 9 meters squared. So in every little square that is 9 meters squared, we have 4 people in it on average. Okay. So what is the density of people eating in the cafeteria? Right here. Okay? Now, what is the ratio of students to teachers? So we have 27 students. We have 9 teachers. So that means there are 27 students to 9 teachers. All right? And that's going to reduce to 3 to 1 ratio. Meaning, per every 3 students, we have 1 teacher. Pretty good ratio. So we calculated the density, and then we calculated the ratio. And you're going to need to be able to use these skills and apply them to different organisms. So let's do that together. All right, so we have, this is just a sampling of a marine environment. So we have the sea stars, and then we have, what are these, like horseshoe crabs? What are these things? Sand dollars. Excuse me. All right, so first thing we're going to do is we're going to look at this first quadrant. All right, so let's say every side, each little side right here is 2 meters long. Meaning from here to here is 2 meters, from here to here is 2 meters, from here to here is 2 meters. You get the picture, okay? So what would our area of this be? So this little square right here is going to be 2 times 2, which makes it 4 meters squared. Okay, that's per one little square. All right, so we are going to look at this one right here. So I want you to think of the ratio of sand dollars to sea stars in this first square. So how many sand dollars do we have? We have 1 sand dollar. 1. And how many sea stars do we have? We got 2. So the ratio is 1 sand dollar to 2 sea stars. Not complicated, right? We got this. All right, so the next thing I want you to do is I want us to do the density. So, excuse me, we have, let's do the density of the sea stars. So that would be 2 sea stars in an area of 4 meters squared. So that would mean there is 1 sea star per 2 meters squared. On average. That means that each sea star has on average about 2 meters square of home, okay? All right, so what if I asked you, what is the density of the sea stars in this whole area? Let's count them. 1, 2, 3, 4, 5, 6. 6 stars. And what is my area for this entire thing? Do we have any ideas? If this is 4 meters squared, then this is 4 meters squared, and this is 4 meters squared. So this whole entire thing is going to be 12 meters squared. So I'll put 12 meters squared. So we're still at an average of 1 sea star per 2 meters squared. So on average, each sea star gets 2 meters squared to call home. Okay, you can calculate the same thing for those sand dollars. 1, 2, 3, 4, 5, 6. So there's 6, so it's the same thing. 6 divided by 12 meters squared is still going to be 1 sand dollar per every 2 meters squared. So we do this because if I just looked at this little square right here, I would think we didn't have very many sand dollars. But what we do is we're collecting data from 3 different spots, and then we're averaging that together to get a better idea of how many sand dollars we have in this larger area. It's just like scientists conduct multiple trials, because just conducting one trial, your data might not be very valid because you could have done a mistake or something. There's writing all over me. Okay, so what if I asked you to sample, I'm going to do a different color, okay. What if I ask you to sample 8 meters squared? Could you do that for me? All right, so that would be, how would I set that up? Do you know how I would set that up? Okay, so 8 meters squared is going to be twice as big as this area, right? So I would predict that there is twice as many. So I would predict that there are 2 sand dollars based on this original density sampling ratio. For the sea stars, I would see that we had 2 sea stars in 4 meters squared. And I want to know, hopefully, yeah, you can still see this, how many are going to be in 8 meters squared? So I just multiply that over, cross multiply, right? So 4x is 16, divide by 4, divide by 4, x equals 4. So I would assume there are 4 sea stars, I'm so sorry it looks like this, in 8 meters squared. So I'm still at 1 for every 2 meters squared. All right. All right, I think that's it. If you have any questions, shoot me an email. Hopefully this cleared everything up.